According to the 2020 National Electrical Code, the sizing of the grounding electrode conductor is determined by the size of the service entrance conductor, not the size of the grounding electrode, such as a ground rod. A table in the code outlines the minimum size grounding electrode conductor that must be used for each size service entrance conductor. For service entrance conductor sizes ranging from number 14 to number 6, the minimum grounding electrode conductor size is number 14. For service entrance conductor sizes ranging from number 4 to number 1, the minimum grounding electrode conductor size is number 8. When service entrance conductors are sized between 1/0 and 3/0, the minimum grounding electrode conductor size required is number 6. If the service entrance conductors are between 4/0 and 250 kcmil, a minimum grounding electrode conductor size of number 4 is required. For a service entrance conductor size from 300 to 600 kcmil, the minimum grounding electrode conductor size is number 3. When dealing with service entrance conductors ranging from 750 to 1250 kcmil, the minimum grounding electrode conductor size is number 2. And lastly, for service entrance conductors sized from 1500 to 2000 kcmil, our number 1/0 grounding electrode conductor is the minimum. Therefore, for a 5/8 inch by 8 foot copper ground rod, considered a 5/8 inch diameter electrode, the minimum size grounding electrode conductor that can be used is number 6. Using a larger size conductor, such as a number 4, would not provide any additional benefit in terms of grounding effectiveness as it pertains to the NEC. It is important to note that in addition to the NEC requirements, some local codes may have specific requirements for the size of the grounding electrode conductor that must be used. It is always important to check with the local code authority to ensure that the installation meets all applicable requirements. The purpose of the grounding electrode system, which includes ground rods and the grounding electrode conductor, is to provide a path to earth for fault current. This helps to ensure that overcurrent devices, such as circuit breakers or fuses, will operate properly in the event of a ground fault. The grounding electrode system also helps to stabilize the voltage to ground during normal operation. The size of the grounding electrode conductor is based on the size of the service entrance conductors because the grounding electrode conductor must be able to safely carry the maximum fault current that could flow in the event of a ground fault. The larger the service entrance conductors, the greater the potential fault current, and therefore, the larger the grounding electrode conductor must be. It is important to select the correct size grounding electrode conductor to ensure that the grounding electrode system will function properly and safely. Using a grounding electrode conductor that is too small could result in a dangerous situation in the event of a ground fault. Ground rods are typically made of copper or copper-clad steel and are driven into the ground to provide a connection to earth. The length and diameter of the ground rod are important factors in determining its effectiveness. Longer and larger diameter ground rods generally provide a lower impedance path to earth. The NEC specifies minimum requirements for the length and diameter of ground rods. The most common size ground rod is 5/8 inch in diameter and 8 feet long. However, other sizes are available and may be required in certain situations. The number of ground rods required also depends on the soil conditions. In areas with high soil resistivity, multiple ground rods may be required to achieve a low impedance path to earth. Ground rods should be installed at least 8 feet apart to avoid reducing their effectiveness. The grounding electrode conductor must be connected to the ground rod using an approved connector. The connector must be suitable for direct burial and must be corrosion resistant. The grounding electrode conductor must be continuous and without splices from the service equipment to the ground rod. The grounding electrode conductor should be protected from physical damage. If the grounding electrode conductor is exposed to physical damage, it should be installed in conduit or otherwise protected. The grounding electrode system should be inspected periodically to ensure that it is in good condition. The ground rod should be checked for corrosion and damage. The grounding electrode conductor and connectors should be checked for tightness and corrosion. If any problems are found, they should be corrected immediately. The NEC provides detailed requirements for the installation of grounding electrode systems. It is important to follow these requirements carefully to ensure that the grounding electrode system will function properly and safely. Local codes may also have additional requirements. It is always important to check with the local code authority to ensure that the installation meets all applicable requirements. The grounding electrode system is an important part of the electrical system. It helps to protect people and property from electrical shock and fire. It is important to install and maintain the grounding electrode system properly to ensure that it will function safely and effectively. Grounding is the process of creating an intentional low-impedance path to the earth. This path allows fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. This protects people from electrical shock and prevents damage to equipment. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding connects all non-current carrying metal parts of an electrical system to the earth. This includes things like metal enclosures, conduit, and equipment frames. The purpose of equipment grounding is to provide a low impedance path for fault current to flow back to the source. This will cause the circuit breaker or fuse to trip, energizing the circuit and protecting people from electrical shock. System grounding connects the neutral point of an electrical system to the earth. This is typically done at the service entrance. The purpose of system grounding is to stabilize the voltage to ground and to provide a path for fault current to flow back to the source. This will help to prevent overvoltages and protect equipment from damage. There are a number of different types of grounding electrodes that can be used. The most common types include ground rods, ground plates, and concrete encased electrodes, also known as UFA grounds. Ground rods are typically made of copper or copper-clad steel and are driven into the ground. Ground plates are typically made of copper and are buried in the ground. Concrete encased electrodes are made of a length of bare copper conductor that is encased in concrete. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The National Electrical Code (NEC) provides a table that specifies the minimum size grounding electrode conductor for different sizes of service entrance conductors. It is important to select the correct size grounding electrode conductor to ensure that it can safely carry the maximum fault current that could flow in the event of a ground fault. The grounding electrode conductor must be connected to the grounding electrode using an approved connector. The connector must be suitable for direct burial and must be corrosion resistant. The grounding electrode conductor must be continuous and without splices from the service equipment to the grounding electrode. The grounding electrode conductor should be protected from physical damage. If the grounding electrode conductor is exposed to physical damage, it should be installed in conduit or otherwise protected. The grounding electrode system should be inspected periodically to ensure that it is in good condition. The grounding electrode should be checked for corrosion and damage. The grounding electrode conductor and connectors should be checked for tightness and corrosion. If any problems are found, they should be corrected immediately. The NEC provides detailed requirements for the installation of grounding electrode systems. It is important to follow these requirements carefully to ensure that the grounding electrode system will function properly and safely. Local codes may also have additional requirements. It is always important to check with the local code authority to ensure that the installation meets all applicable requirements. Grounding is an essential part of any electrical system. It helps to protect people from electrical shock and prevents damage to equipment. It is important to install and maintain the grounding system properly to ensure that it will function safely and effectively. In summary, when installing a grounding electrode system, first, determine the size of the service entrance conductors. Secondly, consult the NEC table to determine the minimum size grounding electrode conductor required. Thirdly, select a grounding electrode that meets the requirements of the NEC and local codes. Fourthly, install the grounding electrode in accordance with the NEC and local codes. Fifthly, connect the grounding electrode conductor to the grounding electrode using an approved connector. Sixthly, protect the grounding electrode conductor from physical damage. Seventhly, inspect the grounding electrode system periodically to ensure that it is in good condition. Always remember to consult with a qualified electrician if you have any questions about grounding. The information provided here is for general informational purposes only and should not be considered as professional advice. Always consult with a qualified professional before making any decisions about electrical work. Grounding electrode conductors connect the grounded conductor of a system to the grounding electrode. The grounding electrode is what makes contact with the earth, and it can take on several forms. The NEC dictates what can be used as a grounding electrode. These include things like metal underground water pipes, metal frames of buildings, concrete encased electrodes, ground rings, and rod and pipe electrodes. Rod and pipe electrodes must meet certain requirements. For example, they must be at least 8 feet long and made of certain materials like copper or steel. The size of the grounding electrode conductor is based on the size of the service entrance conductors or the size of the derived ungrounded conductors. Table 250.66 in the NEC is used to determine the size of the grounding electrode conductor. There are some exceptions to the general rule for sizing the grounding electrode conductor. For example, if the grounding electrode is a concrete encased electrode, the grounding electrode conductor only needs to be number 4 copper or number 2 aluminum. If the grounding electrode is a ground ring, the grounding electrode conductor only needs to be number 2 copper or number 1/0 aluminum. Grounding is a critical safety feature in electrical systems. It provides a path for fault current to flow back to the source, which causes the circuit breaker to trip and energizes the circuit. This prevents electrical shock and equipment damage. Grounding also helps to stabilize voltage and reduce electrical noise. Proper grounding is essential for the safe and reliable operation of electrical systems. It is important to follow the NEC and local codes when installing and maintaining grounding systems. If you are not familiar with electrical work, it is best to hire a qualified electrician to do the job.